So when you have a graph, just grab 3 points. In this case, I labeled them clearly. Just make a table, right? You tell me L1 and L2. This is part of showing your work, right? Like if you come up with 3 points, write them down somehow, and then all you have to do is stat calc quadratic. Like if you write that down, even if you go stat calc, it's 5. I think it's option 5. Like if you were to go stat calc 5, I'm okay with that. I'm doing quadratic because next year you're gonna do cube reg, sinusoidal reg, right? You're gonna do different regressions next year, so I just want you to have that. And then you write down your equation. And if it should be at least 2 decimals, unless it's not, unless this just turns out to be 1 decimal, right? And so you had, and then you check, right? You check, did I do this right? It's positive, it should be pointing up. Okay, yeah, I got it, right? My y-intercept is -14. Yeah, okay, that checks out. Like I would never just blindly trust because you can make a mistake in typing this in. The calculator will still make it work, but it may not be the one you want, okay? So watch out for that. Then I give you another one here where you were given 2 points, but you did not know the third point. And that's when you use the I don't have that work on here, but it would essentially be the, oh yeah, I have it on here, never mind. The axis of symmetry formula, right? Because the vertex gives you that value you're looking for, the x value, right? The x value you get from your vertex, you plug it in here, and you'll be given one of these two here. You actually know 0, right? This first, the y-intercept in this case. And then when you do the math, you get this. And so this principle right here, right? If you start at a certain height and you're given the vertex, right? You will get back to that height eventually, and it is really just double of what it took to get to the middle, right? Like the distance from this leg to the middle is going to be the same as continuing from the middle to the other leg, right? So that's why when you have the y-intercept and you get the middle, just multiply that by 2 to get your third point, or the x value of the third point, and then -3 is just given, right? And then you set up your table of values and entering these. I don't know why I also wrote except that as well. Oh yeah, I know why. Because if you didn't use 3 decimals here in your points, and which is fine, you would have had a slightly different answer depending on what you picked, right? And this is all posted. I'm just talking about it just to maybe clarify things, right? So you have a parabola with a minimum. This word minimum, right, is a horizontal line that would go through the vertex this way, sideways. So since you know the y value, basically know the y value of the vertex here. That's what they're giving you. And they give you the 2 x-intercepts, right? So basically the -4 goes in here as the y value of your vertex. You're going to find the x value, which is really also the axis of symmetry, right? And so in this case, x1 and x2 are given. So you just add them up, which gives you 9, and you divide it by 2, so you get 4.5. So the 4.5 is that middle value, is the vertex. It's basically the halfway point between these 2 x-intercepts that have the same height, right? Obviously, because they're both x-intercept. So then you had your third point there, and once you have your 3 points, you just line them up. The order doesn't matter as long as you keep your x's on the left and your y's on the right. And this is the equation that you should be getting there. And then question 2, basically once you have the equation, I can ask you for this one. Yeah, this one I put a little note that the window will be an issue here. Okay, so what I wanted to show you here, and I wanted to show that here, but I know that I'm going to get to it anyways. So I think it's good to have a warm-up session here. So I'm just going to enter this. Okay, so I'm just going to go -4, -3. If you want to do the same, I'm just going to show you some nuances with the zoom 9. Right, so I'm entering this into L1 and this into L2. Notice that sometimes the tables are horizontal, sometimes they're vertical. Doesn't matter. This is what I can guarantee you, okay? I can guarantee you this also for grade 12. That the first variable is always your x, and the second row in this case would be your y value. Same if they're vertical. If it's a vertical, pins here, right? If it's a vertical table, the first one will always be your x and the second will be your y. They won't trick you on that. We won't trick you, okay? So let's find the regression. So stat calc 5 second 1 comma second 2 comma vars y vars enter enter enter. You get this equation. If you hit graph right now, because this is technically in y1, okay, do not enter when you do a regression, do not enter this manually. I have some students write these down and then they'll round to 2 decimals and enter that, and then it's off, right? So you can tell that I have plot 1 turned on, right? So if you were to go zoom 9 here, it shows you some of the point, like it will only zoom in. Listen carefully. Zoom 9 will only zoom in to the points you have given it, right? Whatever is in stat in L1 and L2, it's going to zoom into those points. So it won't necessarily show you the whole parabola. Sometimes it even looks like a straight line. Like if it, let's say it zoomed into just one little stretch here, if the points were really close together, it may seem like it's a straight line, but it's definitely not a straight line because we're dealing with quadratics, right? So what you need to do here is just make sure your window, right? In this case, you would want to show both sides. So actually a -10 and a +10 would probably work quite well for my x, right? The x variables, there we go. And then you see everything. And these points are not perfectly, like this one here is a little off, and this one, and this would be a real life scenario, right? Like in real life, like when you collect data, when you're launching objects, it's not going to be perfect, right? So you're going to find the best fit of the path, right, that the object went through. And so the issue is here when you're trying to find x equal to 27, right? When you go second trace 1, x is equal to 27, it will give you this. So even though you're seeing at first glance, you're seeing the whole thing, it's a problem. So let's see what happens when you press 2 or go to. It doesn't like the 27, and we know that our x max is 10, right? So we will have to change two things, x max and the y max at the same time. So we're going to increase our x max and increase our y max as well. So window, I know that x max I need to be, I'm going to go 40, and y max I'm just going to go 100 because I don't want to change it too often. It may not even be enough, but let's see if this works. So I did that on purpose so that you would have to figure out what happens when you're out of bounds, right? Oh, it worked in this case, but I can still not see the y value, right? And you're like, Mr. Dirksen, don't you see it's 341? Like, y max should have been 500 or something like that. It's like, yes, I know that, right? I know the answer, but I want you to walk through the steps. Like, if you wanted to see that, you know that your y max right now is only 100, right? So if you change that to 500 and then press graph, you're going to see more of it. And then you can go second trace 1 and hit enter 27 again, and it will actually show up on your parabola, right? And so that's what I want you to be comfortable with. Okay, changing your window if you have to, and so forth. And I'm going to say that now, when you're doing a regression, zoom 9 will not work if plot 1 is turned off, right? Like if that is turned off, zoom 9, like I'll actually show you right now. If I were to go zoom 9, oops, it stopped on me. Why did it stop? Oh, because I pressed enter. I didn't know that. I could pause it. But zoom 9 actually doesn't do anything. It'll just regraph what I already have. But if I turn on plot 1 and then go zoom 9, it will go back to the points that you plotted, right? So zoom 9 doesn't do anything unless plot 1 is turned on, because it needs to know that where L1 and L2 are located, which is done by turning on plot 1. Shake it off, right? Like too much information, but you'll learn as you do the homework, or as we do questions, right? You will only learn math by doing math. Remember that? So true. And the word problem here, if you struggled with it, for now, let's put it on hold. It's after today's lesson where I want you to try and maybe give it another go. If you struggled with it, the answer key is there. And I call this type 0. And you'll see what I mean by that after today's lesson, okay? So don't despair just yet. If you're done, this whole worksheet good for you. There's some more questions down here that I'm going to assign after today, right? If you want more practice on regressions. Okay. So let's grab our notes. I will do the attendance. So I'll ask you to write down the question, yeah. So I'm going to put this up. I'm not going to read it to you. I know that students have said if you read it, then I can just listen and don't have to look at my screen the whole time. But for now, just write it down. But all my handouts were 1, 2, 3 already, and type 0 I introduced after. And so it just made it easier to just introduce type 0. So that's like our ground 0, our starting types of questions, right? And that's where points are given, okay? So these are the points in this particular scenario, right? You have time and height. So make a table like this. I'm going to ask you to write down some questions there. right. I'm gonna give you some more questions, okay, so that we can answer them later. Those are all the questions, in case you're wondering. So enter those into L1 and L2. I hope you're almost done at home. Okay, so let's answer these questions here. A in particular, right? Determine the equation that models the height of the plane over time. And it's going to be a quadratic equation, right? So enter time into L1. You don't have to do this on any assessment, whatever. If you just let me know up here, that's fine, right? And the height into L2, right? So we know that this is our X and our Y, right? Therefore, every single point from now on is going to be time and height, right? Every single point is going to refer to the time first and then the height at that particular time, right? So we're going to go stat calc 5, and we're going to come up with our equation. So at this point, right, let me just clean that up a bit. There we go. So we go stat, edit, and these points are in there already. I already went ahead and did that. Then you press stat, calc 5. If you just did a regression, I would like to save you some time. So let's say I know I did a regression not too long ago. If you go up, arrow up, right, and on your main screen, it's still there. So it saves you from having to go stat calc, right? Because you have changed what's in L1 and L2. So you can just call the same thing again, and then it's there. So that if that saves you a little bit of time, why not use it, right? So there I have 9.375. I'm going to take 3 decimals there, right? So let me just bring this over here. 9.375 x squared, don't forget the x squared, minus 183.750x plus 10,080, and that one would be 001 if you want to go by that, right? If you want to go 3 decimals throughout, you don't have to. If you had rounded everything to 2 decimals, it would have been 9.38 minus 183.75 plus 10,080. It would have been a round number, okay? So that's our quadratic equation. That's what we're going to use from now on. It should be in Y1 stored there, okay? But that answers A, okay? B, it says what was the initial height of the plane prior to performing the stunt, okay? So the initial height is the y-intercept, right? And the y-intercept is 0, 10,080. I know my equation had that, but I'm just rounding to 2 decimals what I'm using when I'm answering here. Either way would be fine. So starting height, initial height is 1080 what feet. Okay, that's important when you answer a question like that. So the initial height is given by the y-intercept, but in particular, it's the 10,080 feet. Okay. See how long did it take to perform the stunt? I don't know. I hope you read the question, right? I'm going to read the question just to make sure. It's like, how do we know when it's over, right? So the airplane performs a stunt at an air show. The stunt consists of a sudden drop followed by a rapid increase in height. The stunt ends when the plane reaches the initial height. Okay. The table below shows the height of the plane at different times. So essentially, if you just want to have a visual, right? Imagine this is time 0, right? The plane is flying, but then at time 0, it makes a drop like this and a stunt and then comes back up to that height. Okay, so if this is our time 0 here, if we have, right, time and height here, then this would be 0, 1080. Okay, and so we can find this here, which is right across. What would be the time at 1080 again? Like, what would be that time here? Okay. Since you have the equation, right? Since we have the equation, no need to use x is equal to x1 plus x2 over 2, right? There's no need to do that. We're just going to say y2, when y2 is equal to 1080, I'm going to go ahead and find that point over here. Okay. I'm going to draw a line at height 1080, right, at this height, and if I find this across here, right, I know how long the stunt took, right? It took from time 0 till you get back to it. So this doesn't have an x-intercept. A lot of our questions had an x-intercept, right? So I had to tell you, when is this over? It's over right here, right? So I will just make an arrow there. Stunt is over. Okay. So let's go ahead and do that on our calculator. Okay. I'm going to go graph this thing first of all, because I'm pretty sure it's not going to be even on the screen, right? Not even going to be on the screen because we put in new points, right? So we have to go zoom 9. Let's see what zoom 9 does for me. And there it is. Not bad, right? And let's go ahead and graph 1080. And let's put it in for y2 and hit graph. And my guess is you're not going to see it. Yeah, you're not seeing that horizontal line, right? So then you investigate. You're like, I'm pretty sure it's something with my window. And what you want to do is pay close attention here. You want to include the origin, okay? So let me go back to my graph. You want to include the corner here where the y-axis meets the x-axis. So I almost by default make my x-min just like -5. X-max, I'm not sure yet, but I'm gonna go 50 on that for sure. I have to increase that because it was cutting off, right? My y min, I'm also gonna go -5. That's almost by default. I wanna just go in just to the left of the axis and just to below the x-axis, right? So that's why you're changing these to -10 or -5, whatever works for you. And my y max, I'm gonna put 1500 or something like that. So go ahead and hit graph after you've done that, and there it is, right? It You're at 1080 when you start your stunt, and then again when you get back to it after the drop. Okay, so we're gonna go second trace 5. Let's go ahead and find that. Oh, I'm way off it seems here. Yeah, I'm already at 7,000, right, my Y, so I have to go to the left till I come back down, and there it is. You have to have your cursor on there, right? So then it's enter, 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 and it's 19.6. 19.6, right? 60, 1080. That's the point that I'm interested in. So it took 19.6 seconds. Oh, hold on. Yeah, go ahead, Jeremiah. What's your question? You can type it or you can say it. Yeah, okay. So if this is what I generally do on my equation, you will see on my keys a lot of times it's 3 decimals, okay? And the main reason I do that is because then I have, like, if I have an answer key and I mark your stuff, I have both roundings readily available. But it's okay. I would say this, right? Because 2 decimals is acceptable. I would just use 1080 here for the work, the actual work thereafter. If you had kept it at 1080.001, you would also get full marks. So both will get full marks. The only problem is if this had been, right, 0.008, then this would have to be rounded to 0.01 if you rounded it to 2 decimals, and then yes, you would lose rounding marks there. Does that make sense? All right, good question. Let's keep going. D, what is the height of the plane at the lowest point, right? So in this case, we have a low point, right? That's our vertex. So we're gonna go ahead and find that. And I think by now you're getting the gist of it, right? Find vertex. All right, we're gonna go second, trace, min, right? That's option 3. And let's go ahead and find that. We're gonna go to the left of our vertex. We're gonna go to the right, enter, enter, and it's 9.799, right? That's 9.80. I put that over here. 9.80, 179.63. And that's where the problem arises, right? Like if you give me a point, that's great, but you need to have one little statement in there where you tell me that it's the lowest point. What's the height? So this is the height. Height at the lowest point is 179.63 feet. E, it says determine the domain and range of the scenario. And I am gonna make a worksheet that is gonna get you to practice domain and range a bit more. I just need to get to it. It's on my to-do list. But trust me, after a bunch of word problems, you're gonna get pretty good at it. Okay. So if you have your domain and range, if you just have like a sketch here, you know that you're going from here and then the action stops here. There's no, right? Like that's the stunt. That's what we're trying to get to. So the domain, right? The domain tells me what the acceptable x values are, and the range will tell me what the acceptable y values are, right? What are acceptable y values? And for the range, you will most likely always need the vertex, and in particular, the y value of the vertex. So for the domain, we're going to go from time 0 till time whenever this ends, which we figured out is 19.6. So in this case, there's nothing you need to find. Sometimes you're going to have to find points to help you out there. Okay? So it's from time 0 to time 19.6. And for the range, you got to always put the lowest and then the highest. The lowest value you ever get to is 179.63, and the highest you ever get to is 1080 inclusive, right? So that's how you look at it, okay? Lowest to highest, and in this case 1080 is the highest. And graph. All right, so graph, I'm gonna grab my ruler. And let's see if I can get this done in about 2 minutes. Time in seconds. Right, in feet. For my time, I need to have, I'm gonna go up like at least till 20, right? So the domain helps you there as well. So 10, so 5, 10, 15, 20, that's pretty good. Sorry, this is supposed to be 10 and then 20. And if I go up to I need to go up to 1080. So maybe go up to, if I go up by 200, what do I get? 2, 4, 6, 8, 10, 12. That works out for me. Right, so I'm marking every other, but really my scale is 200 feet at a time. So this would be 1000, so 1080 is just above. And then I get to 9.8, 179, so that should be right about there. And then I get to 19.6, back to 1080. And that's it. And I think what I'm going to add here is, I don't know where else to put it really. Maybe study sheet, Zoom 9. Only works. Plot 1 is on. Change X-min and Y-min to -5 to include axes. I do that after zoom 9. So I do a zoom 9 and then I will change the mins to -5 or -10, whatever works for you, as long as you see the axes, right? So just going a little bit below it helps. And I will say this. This is in the homework, like on that regression worksheet you worked on. I think it's page 421. Question 18. If you want something just like this, again, it's very similar in fact. I just I changed it up. I asked different questions, but it's a similar idea. I think everybody here is done, I think, writing this down. So I'm going to here I'm going to give you an overview, types of regression. Type 0, points, type 0 points will be given. That's what we did today, and I encourage you to try that as well. Type 1, for now just copy it, right? Type 1 is revenue type questions. Type 2, fencing. And type 3, story. Need to find third point. Type 1, that's the one I'm going to do now. Revenue questions. Make a table with 3 columns. cost, number of items, and profit. Revenue or profit, we treat them the same way. Generally, questions will center around the question how can revenue be maximized? That's the center, like everything else is going to revolve around that. How can revenue be maximized? How can I make the most out of this particular scenario? So we can talk about tickets being sold, items produced, you name it. It will revolve around the vertex, right? This means that you need to find the vertex. Break-even point refers to x-intercept. Can I just add something up here? You know what I asked you to put? We're going to make a table with these three headings. If you have the cost per item and the number of items, revenue or profit, right? Profit is going to be cost times number of items. Like this is basic, right? Like if you make cars and you make $1,000 or it costs you $1,000, right? You'd multiply that by the number of cars you produced to tell you how much profit you made, right? So we're going to do an example here. If 400 kids attend a movie at a school field trip. Not now, not under these circumstances, but I don't want to change my question, okay? The school is charged $1.80 per ticket. For every 10-cent increase in ticket price, 40 fewer tickets are expected to be sold. And here come the questions. By the way, whenever you see dollars, you know it's going to be a revenue question, okay? Like if they're talking about like how much each item costs and stuff like that, and if you see profit or revenue, you know it's this type, okay? So on your study sheet, make sure you have each type and how to solve them, right? Determine the quadratic equation relating the number of tickets sold and the profit. B, determine the equation relating the price per ticket and the profit. C, what price result in the maximum profit? What price would result in the maximum profit? D, how many tickets would you expect to sell in C? What is the maximum profit? F, what ticket price or prices would yield? That's an interesting word, but yield is the same thing as give. Profit of $450. So write this down. There are two more. Wasn't able to fit that on here. G, Determine or state the domain and range. Using the equation in B. Graph price versus profit. And I know I'm pushing it a little bit, folks at home, but I would like to get at least to C or D before the bell, so I can clarify tomorrow. Okay. So for A, what we're going to do there is make a table like this. Okay. So we normally have the price or the cost of whatever we're talking about first. Right? And then we have the number of items that are being made or sold. And we have a profit column here, which we know that the profit in each scenario that we're going to run by is going to be the price times items. That's how you would come up with the profit, right? So you make a table like this. And the nice thing about this first case is that they tell you basically how to come up with the points. Okay? So it says, if you read the question, I hope you have the question in front of you, but it says if 400 kids attend a movie at a school field trip, the school is charged $1.80 per ticket. I will tell you this, these two columns do not matter in which order you put them in as long as you have the profit at the end here. Okay, so if you're like, what was price first and then number of items, it doesn't matter. But we know that if it's $1.80, they're charging them $1.80 when there are 400 students, and we know that the number of items are our tickets, right? In this particular case, it will vary. So $1.80 per ticket when 400 are sold. The profit under that circumstance would be $1.80 times 400. Okay, just like that. And then something happens. One of them will go down, right? Or up, and the other one will do the opposite. So it says that if the price drops by or goes up for every 10-cent increase, if we were to increase that by 10 cents, this would turn to $1.90, right? But there would be 40 fewer tickets sold. So that means that you would end up selling 360. So here we went minus 40. 40 fewer would be sold. So if the price increases, this drops. And so under that circumstance, right, your profit per ticket or your cost per ticket is 90, and you'd only sell 360 tickets. And this continues. How many points do you need again for, sorry, this was plus. How many points do we need for a quadratic? 3. So you're gonna have to do this for 3 rows, okay? And so if you increase it one more time, you get to $2. This would now drop because it's happening again and again, and you're kind of giving the scenarios, right? So you would drop again, you would drop by 40, so that gets you to 320, and the profit there would be $2 multiplied by 320 tickets sold. Okay, so there you have your basically 3 points. You don't see them yet, but they're there. Okay, so this is my table completed, right? You don't need to make it nice and fancy, just make sure you have that, right? And so for A, what does A ask? I'm going to go back and read it to you. Determine the quadratic equation relating tickets sold and profit. So you're going to relate tickets. Oh, let me give some room there. I need a little bit of room underneath, like this. Tickets and profit. That's what I'm relating, okay? I want these two. So where are my tickets under these 3 columns? Which ones are the tickets? It's this one right here, right? So you would type these things into L1, okay? And you would type this one into L2. Right, so you're going to put L1 and L2 in like that in your calculator. So let's go ahead and do that, okay? We're going to say this, turn this on, go stat, edit, clear whatever is there, and we're going to go 400, 360, 320. And then on the other side, watch this carefully. This is a nice trick. You can go 1.8 times 400, like type that in, and then hit enter, and it will calculate that for you, and then you go and write down 720, right? So 1.9 times 360, that's 684. Okay, and then 2 times 320, we know that that is going to be 640. So then you have the actual value, but I would encourage you to just type this in to not make mistakes, and there could be rounding issues too down the road if you don't type it in exactly what you got here. Now we're going to go stat, calc, 5, and I'm going to do this a little faster. I know I told you to copy it. If you did that, good for you. And this is the equation. It's a nice, so we went tickets went into L1 and profit went into L2, right? And then I went stat, calc, 5, and this is the equation I get. And because it stops, it's finite. I'm going to write down all decimals, okay? It is finite. So plus 2.8x. And that is the equation. This equation, folks, relates the number of tickets and the profit. Right? This one right here relates the tickets and the profit. So every X point is going to be the number of tickets you sold and the amount of money you made at that particular instance. Okay? And now I'm thinking you're going to go back in your notes, and I already know what I'm talking about, but can I ask you to do this? Just erase this one here. The L1 that I told you to put on that table, because I know you're going to be like, oh, just put that one in every time. Nope. This one always goes into L2. Profit always into L2, right? This last column will always go into L2, but L1 will depend on the wording of the question. Because it says tickets and profit, that's why I put this one into L1 and that into L2. B, I know you're like, that's too fast. I can clarify as we go, okay? B is asking, determine the equation relating the price per ticket and the profit. So now we're gonna compare these two. Okay? And what we're gonna do is we're gonna put the price into L1 and the profit into L2. And it's actually very easy to do this, folks. Stat calc 5. Don't type anything in yet. I'll show you the shortcut. So if you go to stat edit, let's see if you're with me here. Does the profit change at all? The profit will not change. It doesn't matter which one you type in. The profit will still be 720, right? So I leave L2 as is. I just go to L1 and I just put in 1.8, enter, 1.9, enter, 2, enter. That's it. So you change this, but don't change the profit because it stays the same, right? And then I'm going to do the shortcut. Second quit. I'm going to go arrow up, borrow the, you have to perform the regression again because you changed L1, right? Hit enter, and here you go. It's negative 400 x squared plus 1120x. You're like, they're different. Yes, they are, because they're relating different things. If you graph this guy, you'll have the price on the x-axis and the profit on the y-axis. If you graph this top one here, you'll have tickets on the x-axis and the profit on the y-axis. So that's how they're different. And from now, I'm going to ask you to stick with this one, okay? We're not going to go back and forth. I just wanted you to see that it is possible to get a wrong or the wrong equation if you type in the wrong number. Another thing I want to tell you, and this is on record, okay? I'm recording here. It happens a lot of times, maybe not right away, but 2-3 months from now. Students put this into L1 and then this into L2, and they get a linear equation. You can't have a linear. It will actually go 0x squared plus something something, and then students think, oh yeah, that's right. They just write it down and they don't think about it. It's like, no. That's why if you put L2 on, if you put that last column into L2, it will never happen. But just be aware of that, okay? C is asking what price would result in the maximum profit. We know that we're going to have to find the max, right? So the vertex we're going to get here, and now we have to figure out if this is going to be on our screen. So I'm going to go, and remember, it's asking what price would result in the maximum profit. So we can use this equation, which is already in our y1. So hit graph, and I'm going to go zoom 9 here. Oh, I never erased the 1080 from the other word problem there, so I'm going to get rid of that. I'm going to hit graph again. It's on there, all right, but I'm going to go zoom 9 just to show you what happens. It looks like a straight line, right? But you're going to go window, change your x min to like -5, change your y min to -5, and then hit graph. Sometimes that lets you see a lot more, right? So you see this, so you just need to increase your y max and your x max. I'm going to go x max 10, y max I'm going to go 1200 or something like that. And there it is. Now you see the whole thing. And it's at this point right here, notice, right? The y is your profit. So the highest point will give you the maximum profit. So second trace 4, go to the left of it, enter, go to the right of it, enter, enter. So it's 1.40, 784. Right? That's the point I'm interested in. Maximum profit will be obtained at a price of $1.40 per ticket. It's not the 784. The 784 is actually the profit, the highest profit you'd be making. So you are still interested in the vertex. It's just this is the amount you write down. How many tickets would you expect to sell at this price? Recall, right, that profit is equal to price times items, right, or tickets in this case. So you know your profit at 784. You know the price per ticket that you're charging at that particular point, right? And it's the items, right, which we're going to call X here. That's what's unknown. So you can actually just use this equation to come up with it. So we're going to divide both sides by $1.40. And you're left with X. And that's 560. So 560 tickets are expected to be sold at that price. If you sell them for $1.40, you are expecting 560 tickets to be sold. And just test it, right? If they're $1.40 and you sell 560, if you multiply that, you should get the 784 that you started off with, right? At this highest point there. E, we can answer that briefly, and then the rest I'll do tomorrow. Maximum profit is 700. Make sure you have units here, $784. Okay. You get that from there. Homework. Page 12 and 13. In your booklets, okay? There's a type 0 and a type 1, like which we did today. That's it. And I will post the answer key as soon as you leave, okay? Have a good one, guys. Sorry.